have about 6 slides covering lipid digestion and absorption that I want to cover here. Kind of an overview of this process, what we're looking at. We see that lipid digestion actually occurs before stomach or the contents ever reach the stomach. In the mouth, we have an enzyme called that lingual lipase. It's going to be secreted, and even though we don't have a huge amount of digestion occurs here, it will start breaking down some of those triglycerides. And then once those lipids reach the stomach, we'll have additional digestion that occurs, and this is due to the help and secretion of gastric lipase that is produced in the stomach. And now this is going to continue to break down some of those triglycerides. However, not a huge amount, again, has happened here. The majority of lipid digestion, is going to occur in the small intestine. And that's going to start off by the production of bile. Remember, we have got bile that is produced in the liver. It's kind of in holding in the gallbladder. And then once we have fat that reaches the small intestine with the help of some hormones like cholecystokinin that's released from the pancreas into the small intestine, it's going to trigger that bile to be secreted, goes into the small intestine. We're going to have some additional breakdown. The next slide is going to cover this at a kind of a better view here. Okay, guys, we have to kind of assume that this is a closer look from what we just looked at, and this, if you bear with me here, if this is our liver, then of course our gallbladder is going to be located kind of behind this area, in this range. We're going to have a common bile duct that is going to connect to the liver and then also into the small intestine. Cholecystokinin and other types of hormones are going to stimulate the release of bile into the small intestine, and that's what's going to help to take big globs of fat and break it down into smaller, more accessible little small lipid drops. And then we have, let me change this. So this kind of view of what's occurring with the bile. So our bile is full of bile salts, which are going to have a hydrophobic side over here and a hydrophilic. And because you have this bipolar action occurring, it's really pulling like two opposite magnets apart, and it's making this go from bigger to smaller droplets. And what that does is now we got a greater surface area so that enzymes like lipase can get in there and begin to break down those triglycerides into smaller forms like diglycerides and monoglycerides and free fatty acids. So what our end result is like kind of a big glob that just packed up triglycerides into monos, dies, and free fatty acids. And then the next step that we'll look at is a micelle, which is going to look very similar to this. It's just kind of it's the same thing, except for now we have a bigger mass of broken down triglycerides, monos, dies, and free fatty acids. Okay, guys, so this is where we just came from. We had the big fat droplet here. We have emulsification from or through the help of bile salts. Now we have taken those triglycerides, broken them down with the help of lipase here into diglycerides, monoglycerides, also some free fatty acids. And now we have them kind of all hanging out here in the middle. Around this is some more phospholipids. Remember that phospholipids help the emulsification, and also it helps to transport through the watery environment here within your intestine. So let's kind of take this and go on up to here. So here's our micelle, package full of free fatty acids, monoglycerides, diglycerides, etc. Now it can move, because of the phospholipids around it, it can move through the watery environment and get close enough to the brush border to be absorbed into the intestinal lumen. So this is your mucosal cell, and our whole goal is to get the digestive foods from here into here. But because of the way fat kind of reacts to water, we have to have this whole certain mechanisms to get them close enough for absorption into the enterocytes. All right, so the next thing that we're going to look at is what happens once it gets into the enterocytes. Now, it's kind of strange, but our body has done a ton of work to break these triglycerides down into monos and free fatty acids and diglycerides to get them in here. But once they are inside the mucosal cells or enterocytes, they're going to be reassembled back into triglycerides. They only had to be small enough to get in here. Now we want them back into the triglyceride form. Once they are reassembled, they'll be packaged into chylomicrons. Now, chylomicrons, just kind of think of them looking a little bit like micelles, but a little bit more detailed when it comes to the amount of proteins and phospholipids that are surrounding them. These chylomicrons themselves, they're too large to really enter the bloodstream directly, so they have to enter into the lymphatic vessels. The lymphatic vessels are going to go through, eventually meeting up into the hepatic portal vein and eventually to the lipids as well. Now, not all of our digested lipids here have to enter through a chylomicron. In fact, some of them, like glycerol, which is the glycerol backbone, some short chain fatty acids, and also some types of medium chain fatty acids can enter directly into the bloodstream like we saw with carbohydrates. But the longer ones here, they have to have this special mechanism called a chylomicron. I want to just take a second here just to make sure that you are aware they're going to have some different mechanisms that you need to be able to distinguish. So here's the test questions here. The micelle helps to get the digested fats or triglycerides and free fatty acids into the mucosal cell. So from the lumen inside of the small intestine into the mucosal cell. The chylomicron, even though it looks the same, is going to help to get those triglycerides into the lymphatic system for absorption. So this is more digestion, this is more absorption here. Now that we understand how lipids are digested and absorbed, the next really big question is how do they travel through the body, and especially considering the fact that lipids don't mix well with water. So remember that blood and lymph are water-based environments, and fat does not dissolve in water. So the body had to really design something really extravagant in order to transport these lipids, in order, to be able to get the nutrients that are inside of them and to be able to perform all those functions. So what we have are lipoproteins. Lipoproteins are classified as really by their density and how they function within our body. Density refers to the ratio of fat versus protein. So the more protein that is present in these lipoproteins, the denser it is said to be. The more triglyceride that's present, the lighter and larger the particle is. So let's kind of walk through them in order. First, we have these chylomicrons over here. These are the largest lipoproteins, and they contain the highest proportion of triglycerides. They're formed in the intestinal cells, and then after fat absorption, their real job is to transport dietary triglycerides from the intestine and to the muscle and adipose tissues. So you kind of have to think of chylomicrons as freshly delivered packages straight from your meal. They got all those fats from your food. Next, the one that we're going to look at next is these VLDLs. That stands for very low density lipoproteins. What you see, you have a high amount of triglycerides, this color of the orange here, and then you have a smaller amount of protein. While these chylomicrons really contain a lot of triglycerides that your liver has manufactured, it delivers these triglycerides primarily to the muscle and the fat tissues. As the VLDLs travel through your bloodstreams and such, they become smaller. So they're dropping off or depositing some of these triglycerides, and that's why it begins to get smaller. So you have to think this is the original one, and they eventually begin to turn into these smaller ones. That's where this can stop, because we have chylomicrons. These went to the liver. We have these that the liver's producing, so going into the liver, leaving the liver. So as we get rid of some triglycerides, because your body needs that for a whole bunch of different things, it gets smaller and you end up with something called a low density lipoprotein. And now if you look at the percentage of this, you have a greater proportion of cholesterol than you do with others. So even though this is a large amount of triglycerides, a large amount here in relation to the triglycerides versus cholesterol. And that's why you say that the LDL cholesterol, oftentimes referred to as bad cholesterol, is the one that is least heart healthy. Our body still needs it to perform some functions, though. And unfortunately, this cholesterol that's in this and very dense is very bad about getting into some of those interstitial tissues. So too much of those is going to cause or increase the risk of atherosclerosis, the development of kind of those plaques within your arteries. Now, our last one here is the HDL. The HDL has the greatest amount of protein. That's why it's known as high density lipoprotein. So this is going to be a test question here. Which one contains the greatest amount of protein? Which one contains the greatest amount of cholesterol? And then which one contains the greatest amount of triglycerides? So now you can see that very plainly for yourself. This just gives a different view. What those yellow little dots are representing are those phospholipids. You got some proteins in here. You can see inside, if we hatched it open, we're going to see a lot of triglycerides, monoglycerides, cholesterol, all those types of lipids from our digestion. These are just carriers, these lipoproteins are. All right, so, and then we have the HDL. That is highest in protein because its job really is to take anything that's left over and circulate it back to the liver. It's safer in the liver than it is out floating throughout your bloodstream. So that's why this is kind of the cleanup crew. It's helping to get those back out of the bloodstream and into the liver. All right, the last thing I want to show you is this video because I really feel it brings all this process to life. I don't want you to sit here and think about memorizing what these are, but think about this as a very dynamic way that your body takes lipids and transports them in various different mechanisms. So we have some that are going from the liver into the blood system and into tissues, some that is kind of taking it and bringing it back to the liver. Now, this is also available to you in your study material, so you're welcome to go ahead and stop this here, look at it later on, or use this as part of your studying as well. I want to mention this one thing, lipoprotein lipase, because I did not mention it earlier. This is the enzyme that helps to take these triglycerides out of the VLDL lipoprotein and release it into your tissues, and same thing when it comes to the low density lipoprotein. You have to have an enzyme always in order to take something from bigger to smaller. So lipoprotein lipase is that.
Lipids are a class of hydrocarbon-containing organic compounds. Lipids play diverse and important roles in nutrition and health. Many lipids are absolutely essential for life. Lipids are transported in the bloodstream by lipoproteins, which are an assembly with the lipid at the center and a protein outer coat. Lipoproteins fall into three categories: VLDL, very low density, LDL, low density, and HDL, high density. They are defined by their density or the amount of protein they contain, as well as their role in the development or prevention of heart disease. Very low-density lipoproteins, or VLDLs, are primarily formed in the liver. VLDLs function to transport triglycerides from the liver to the rest of the cells, including adipocytes, for storage. As the VLDL moves along the bloodstream, the enzyme lipoprotein lipase cleaves the triglyceride from the lipoprotein to be taken up by the cells. When the VLDL loses its triglyceride, the protein content increases, making the lipoprotein more dense. It is now categorized as a low-density lipoprotein, or LDL. LDL is the form of lipoprotein often called bad cholesterol because of its implication in the development of heart disease. It delivers cholesterol to cells with specialized cholesterol receptor sites. HDL, or high-density lipoproteins, are released from the liver to travel throughout the body, picking up cholesterol from dying cells and arterial plaques. The cholesterol is then returned to the liver, where it is used to synthesize bile. This form of lipoprotein is often called the good cholesterol because it reduces plaque buildup in the arteries. While each type of lipoprotein has a function in the body as a transport mechanism, maintaining a balance between LDL and HDL is essential for preventing cardiovascular disease.